So looking at similar triangles here, and if we look at these two triangles, there are two triangles here, there's one on top of each other. They're identical, these two triangles, because if you put one on top of each other, it fits exactly. Therefore, these two triangles are called congruent. And congruent triangles have three angles equal and three sides equal. That means that every angle matches up with another angle. So for here, this angle would equal that angle, that one would equal that one, and this one, which is a right angle, would equal that one. Also, the three sides would match up. That would equal that, that would equal that, and this one would equal that one. And that is what we mean by congruent triangles. Now for similar triangles, slightly different. The triangle does not have to have the same length, but they will have the same angles. And you can see here that there's congruent, and now the two triangles are similar. And because these angles are equal, so you've got this angle equals that angle, that one equals that one, and of course this one's shared, what you end up with is these lines being parallel, by definition, alternate interior angles. So now we have these two similar triangles. Of course, the other thing, they can now tell us that these angles, so these triangles now are able to twist and not look the same as the other angle, and this is what we've got here. So here, these two triangles are still similar, even though one is completely askew to another. One thing we know about similar triangles is that the sides will all be in the same ratio. So right now, if these two triangles are similar, which we know they are, the ratio is 5 to 10, which reduces to 1 to 2. So if this here was 4, then this here would have to be 8. If this here was, I'm trying to think what it is, because 16 plus 20 is root 41. This would be 2 root 41. And the reason I know it's root 41 because by Pythagoras, 4 squared plus 5 squared is 16, plus 25 is 41. This must be root 41. And you can prove it here. 8 squared is 64, plus 10 squared 100 is 164. And root 164 is broken up. Root 4 times root 41, which is 2 root 41, as we predicted. So here we have two triangles. I'm going to say that this length here is 8, this length here is 6, this length over here is 10, and we've got to find x. Well, we know they're similar because that would have been given to us already. That angle equals that angle. So all we need to prove similarity is that the three angles equal each other. Well, of course, if two angles equal each other, i.e. the reds and the blues, then by definition the blacks must equal each other as well. So we know they're similar. We know that this side here, the 8, is the matching side, the corresponding side to the 6. So 8 over 6 is the ratio. And their similar ratio for the other sides would be 10 over x. And we solve this by algebra. Cross multiply, 8 times x is 8x, 6 times 10 is 60. So x is 60 over 8, which works out to be 7.5. So therefore the missing side is 7.5. Interestingly enough, the ratio of these two triangles, the ratio of length that is 6 to 8, which is 3 to 4 when it breaks down. The ratio of areas is going to be connected. It's going to be 3 squared to 4 squared, which is 9 to 16. So if this triangle here had an area of 64 centimeters squared, then what would the area of this one be? So you'd set your ratio up 9 over 16. 9 being the area of the small one, so the x is the area of the small one, over 64. So 9/16 is the ratio of areas. Cross multiply and we get 16x on the right hand side. 9 times 64, 540, 576 I think it is. And if we divide 16 into that, we can get, good question, 36 I think it is. And x is 36 centimeters squared in this case.